Hello and welcome to the science class. My name is Teacher John. I'm going to teach you science primary 7, term 2, a topic called simple machine and friction. Simple machines and friction. And we were looking at classes of levers, classes of simple machine. And the class of simple machine we are looking at today is called wheel and axle. In our previous lesson, we looked at screws, and we said a screw is an inclined plane wound round. We gave uses of screws. We said screws, they help in fastening things together or holding things together tightly. So in today's lesson, we're going to look at wheel and axle. Now, an axle is a rod passed through a wheel. An axle is a rod passed through a wheel. Then the wheel rotates on the axle. The wheel rotates on the axle. So we are going to look at examples of wheel and axle. One, we have what we call doorknob. Doorknob. A doorknob is an example of a wheel and axle. Then number two, we have pedal wheels. Pedal wheels. Pedal wheels. Then we have what we call steering wheel. Steering wheel. Steering wheel. Number four, we have windlass. Windlass. We have handles of a bicycle. Handles of a bicycle. Handles of a bicycle. Then we have egg beaters. Egg beaters. Number seven, we have screwdriver. We have screwdriver. Number eight, we have a brace. We have a brace. We have a brace. So those are examples of wheel and axle. We say we have doorknobs, pedal wheels, steering wheel, windlass, handles of a bicycle, egg beaters, screwdriver, and a brace. So those are examples. We are going to look to draw some diagrams. We are going to draw a bit of some diagrams, around 4 of them, so that you can know where the wheel is and where the axle is. We shall begin with steering wheel. Steering wheel. Look at a steering wheel. Now with a steering wheel, shall begin by drawing the wheel. We draw the wheel. So this one is a wheel. Then this one is called axial. That's why it's called a wheel and axial. This is a wheel, this is the axial. And that's why we say an axial is a road passed through a wheel. An axial is a road passed through a wheel. So an axial is attached to the wheel. That's why it's called wheel and axial. Then the wheel rotates on the axial. The wheel rotates on the axial. So that's one example. Then number two, we draw a screwdriver. A screwdriver. A screwdriver. A screwdriver. So this one is called a screwdriver. A screwdriver. So that's a screwdriver, is an example of a wheel and axial. Then next we look at windlass. Windlass. So that is a windlass. A windlass. So this one is called a windlass. So this is the wheel. This is the wheel. Then this one is the axle. This one is the axle. Remember we said an axle is a rod that passes through the wheel. So the axle is that rod which goes through the wheel. So this is a wheel, then this one is the axle. This one is the axle. That's why it's called wheel and axle. Wheel and axle. Then this is the bucket of water. So basically it helps in drawing water from underground wells. It helps in drawing water from underground wells. So that is the diagram showing a wheel and axle. Then next we look at a brace. We draw a brace. A brace. Alright, so we begin drawing a brace. So this one is called a brace. And it's called a brace. So it's an example of a wheel and axle. We look at uses of wheel and axle. Uses of wheel and axle. Uses of wheel and axle. Now, we shall begin by looking at a windlass is used to draw water from underground wells. A windlass is used to draw water. A windlass is used to draw water from underground wells. From underground well. A windlass is used to draw water from underground wells. Then, number two, a brace is used to drill holes in wood. A brace is used to drill holes. A brace is used to drill holes in wood. So if you want to drill holes in wood, we use a brace. We use this one here. Then number three, a screwdriver. A screwdriver is used to loosen screws. A screwdriver is used to loosen screws. Or you can say a screwdriver is used to make screws loose or to loosen screws. Then egg beaters are used to prepare eggs for frying. Egg beaters are used to prepare eggs for frying. Egg beaters are used to prepare eggs for frying. Then we can also say a steering wheel is used to steer vehicles. 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 So that's how wheel and axle is important. One will say the windlass is used to draw water. A windlass is used to draw water from underground wells. A windlass is used to draw water from underground wells. Then a brace is used to drill holes in wood. A screwdriver is used to loosen screws. Egg beaters are used to prepare eggs for frying, and a steering wheel is used for steering vehicles. A steering wheel is used for steering vehicles, especially when you are driving a vehicle, you need a steering wheel. So that's how wheel and axle are important. That's how wheel and axle are important. So next, we look at pulleys. We look at pulleys, and that's going to be our next class of simple machines. We look at pulleys. What is a pulley? What is a pulley? A pulley is a wheel with a grooved rim. A pulley is a wheel with a grooved rim. A pulley is a wheel with a grooved rim. A pulley is a wheel with a grooved rim. A pulley is a wheel with a grooved rim. Let's look at the importance of pulleys. Importance of pulleys in our daily life. Importance of pulleys. How are pulleys important to people? Importance of pulleys. Importance of pulleys. Number one, pulleys are used to raise building materials during construction. Pulleys are used to raise building materials. They are used to raise building materials. Pulleys are used to raise building materials during construction. During construction. That's how pulleys are important. They are used to raise building materials during construction. Number two, pulleys are used in loading heavy goods on vehicles. Pulleys are used in loading. They are used to load. The pulleys are used to load Pulleys are used to load Pulleys are used to load heavy goods, to load and offload. Okay, to load heavy goods on vehicles. Pulleys are used to load heavy goods on vehicles. Number 3, you can say pulleys are used to offload heavy goods on vehicles. Pulleys are used to offload heavy goods on vehicles. Pulleys are used to load heavy goods on vehicles. Then they are used to raise flags on poles. 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 Then pulleys are used in moving, they are used for moving window curtains. Pulleys are used for moving window curtains. They are used for moving window curtains. Pulleys are used for moving window curtains. Then you can also say pulleys are used to draw water from underground wells. They are used to draw water from pulleys are used to draw water from deep wells, or pulleys are used to draw water from underground wells. To continue by looking at uses of pulleys, you can also say pulleys are used in drawing soil from deep pits. They are used to draw soil from deep pits. They are used to draw water from deep pits. They are used to draw water from deep pits. They are used to draw water from deep. They are used, not water, they are used to draw soil. They are used to draw soil from deep pits. Then lastly, they are used in lifts or elevators. They are used in lifts. They are used in lifts or elevators. They are used in lifts or elevators. They are used in lifts or elevators. Right, elevators here. So these are pulleys are important. One, we say the pulley is a wheel with a grooved rim. A pulley is a wheel with a grooved rim. Importance of pulleys in our daily life. They are used to raise building materials during construction, especially when they are constructing flats, when they are constructing storage buildings. Sometimes they use pulleys to lift building materials like sand, cement, stones, bricks can be lifted using pulleys. Then number two, they are used to load heavy goods on vehicles. They are used to load heavy goods on vehicles. So there are some goods which cannot be carried by hands. So they can be loaded on vehicles using pulleys, and the same goods can be offloaded using pulleys because they are too heavy. Then number 4, they are used to raise flags on poles. Pulleys are used to raise flags on poles. Number 5, they are used for moving window curtains. There are some window curtains that use pulleys. Number 7, they are used to draw water from deep wells or underground wells. So we can use pulleys to draw water from deep wells or underground wells. Then number 7, pulleys are used to draw soil from deep pits, especially when they are digging pit latrines or if they are digging boreholes. Sometimes pulleys can be used to remove or to lift soil from deep pits. Then lastly, pulleys are used in lifts and elevators. Pulleys are used in lifts and elevators. There's one which we have not put. Number 9, you can say they are used. Pulleys are especially vehicles with mechanical problem. They can be towed or pulled using pulleys. So pulleys are used to tow vehicles. They are used in towing. They are used in towing vehicles. Pulleys are used in towing vehicles. To tow is to pull. So if vehicles get accidents, sometimes they can be pulled or towed using pulleys. So that's how pulleys are important in our daily life. That's how pulleys are used in our daily life. They are also used in lifts and elevators, especially if you are moving in storage buildings. As simple as that. Next, we look at types of pulleys. 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 We have 3 types of pulleys. One, we have what we call a single fixed pulley, single movable pulley, and then block and tackle pulley system. We have 3 types of pulleys. One, we have single fixed pulley. Single fixed pulley. Number 2, we have single movable pulley. Single movable pulley. Then we have block and tackle system. Block and tackle system. Block and tackle system. Block and tackle system. These are the 3 types of pulleys. So we begin by looking at a single fixed pulley. A single fixed pulley. A single fixed pulley. Single fixed pulley. Single fixed pulley. Now with a single fixed pulley, the effort applied is equal to the load. The effort applied is equal to the load. It changes the direction of force, then it changes the direction of force. How? By applying the downward force. So we can say it also has a mechanical advantage of 1. You can say 1, the effort applied the effort applied is equal. The effort applied is equal to the load. The effort applied is equal to the load. The effort applied is equal to the load, then it changes the direction of force. A single fixed pulley, it changes the direction of force. It changes the direction. Changes the direction of force. A single fixed pulley changes the direction of force. So the effort applied is equal to the load, then it changes the direction of force, and work is made easier by applying downward force. So by applying downward force, work is made easier. So I've just given you characteristics of a single fixed pulley. Characteristics of a single fixed pulley. You said the effort applied is equal to the load. Then you also said changes the direction of force. Then it has a mechanical advantage of 1. It has a mechanical advantage of 1. It has a mechanical advantage of 1. So a single fixed pulley, its mechanical advantage is 1. Reason the load applied is equal to the effort. Remember we said mechanical advantage is equal to load out of effort. So when you divide, you find that it is always 1. So we draw a diagram showing a single fixed pulley. A single fixed pulley. A single fixed pulley. A single fixed pulley. Now with a single fixed pulley, we say the effort applied is equal to the load. Let's draw a diagram showing a single fixed pulley. You can have this. So this is the effort. Then this is the load. So that's a single fixed pulley. You say the effort applied is equal to the load. So this is a single fixed pulley. It has a mechanical advantage of 1. If the load is 10 kilogram force, the effort will also be 10 kilogram force. And we say its mechanical advantage is 1. Reason, the load applied is equal to the effort. So you can write NB for a question. Why is the mechanical advantage of a single fixed pulley? Why is the mechanical advantage of a single fixed pulley 1? Why is the mechanical advantage of a single fixed pulley 1? It is 1 because the load applied is equal to the effort. The load applied is equal to the effort. That's why its mechanical advantage is 1. So we are going to look at examples. We calculate the mechanical advantage. Number 1, I write examples. If a load of 30 kilogram force is to be raised using a single fixed pulley, if a load of 30 kilogram force is to be raised using a single fixed pulley, find the for that, if a load of 30 kilogram force is to be raised using a single fixed pulley. Using the effort of 30 kilogram force. Find the mechanical advantage. If a load of 30 kilogram force is to be raised using a single fixed pulley, using the effort of 30 kilogram force, find the mechanical advantage. So we say mechanical advantage equals to load out of effort. Mechanical advantage equals to load out of effort. Mechanical advantage equals to our load is 30 kilogram force. and the effort is also 30 kilogram force. Kilogram force comes with kilogram force, 30 here 1, 30 here 1, meaning that the mechanical advantage is equal to 1. The mechanical advantage is equal to 1. That's why we are saying the mechanical advantage of a single fixed pulley is 1. Question number 2. Question number 2, example number 2. Example number 2. They are saying, number 2, the diagram below shows a single fixed pulley. The diagram below shows a single fixed pulley. Find its mechanical advantage. Find its mechanical advantage. The load here is 40 kilogram force, and the effort is also 40 kilogram force. So it's supposed to find the mechanical advantage. Simply say mechanical advantage equals to load divided by effort. Then you come and say mechanical advantage equals to, our load is 40 kilogram force and the effort is also 40 kilogram force. Kilogram force, they cancel. 0 cancels with 0, 4 cancels here, cancels with 4. Then we shall say mechanical advantage equals to 1. The mechanical advantage equals to 1. The mechanical advantage equals to 1. So we do something else. If you have been given, now we know the mechanical advantage, how can we calculate the effort? For example, if a load of 30 kilogram force is to be raised, that's example number 3. If a load of 50 kilogram force, if a load of 50 kilogram force is to be raised using a single fixed pulley, find the effort needed. Find the effort needed. Find the effort needed. Now, if a load of 50 kilogram force is to be raised using a single fixed pulley, find the effort needed. So this question is supposed to find the effort. We know the load, we don't know the effort, but the mechanical advantage is obvious. It is 1 because we say a single fixed pulley has the mechanical advantage of 1 simply because the effort applied is equal to the load. So if you want to find the effort, you come and write the formula. Mechanical advantage is equal to load out of effort. The mechanical advantage equals to load out of effort. What is our mechanical advantage? Is 1. Our load is 50 kilogram force. Then our effort, we don't know. So one thing you must know is you must know the mechanical advantage. And we say the mechanical advantage is 1. The formula is mechanical advantage equals to load out of effort. What's our mechanical advantage? Is 1. Remember we said a single fixed pulley has the mechanical advantage of 1. So the load is 50 kilogram force, we don't know the effort. The question is telling you, find the effort needed to raise a load of 50 kilogram force. So we shall come and say mechanical advantage equals to load out of effort. Then we substitute. Our mechanical advantage is 1. So we shall say 1 is equal to, our load is 50 kilogram force. Our effort is E. So how do we find the effort? How do we find the value of E? We multiply both sides by E. Multiply even this side by E. E cancels with E. 1 times E, we get E. Then we remain with 50 kilogram force, and that would be the effort. So you see that the effort is equal to the load. The effort is equal to the load. So this is how we calculate the effort. Remember, you've not been given the mechanical advantage. You've not been given the mechanical advantage, but you know very well that the mechanical advantage of a single fixed pulley is 1. So once you know that, then the rest falls in place. As simple as that. Then maybe the last one, the last example before we end. I want to give you another example. That's example number 4. Example number 4. So we shall say, if a load of 20 kilogram force is to be raised using a single fixed pulley, find the effort. Find the effort. So we shall say 1, what is our load? Our load is 20 kilogram force. What's our mechanical advantage? Our mechanical advantage is 1. And what's our effort? Our effort, we don't know, and that's what we're going to find. So we come and write the formula and say mechanical advantage equals to load divided by effort. Load out of effort. What's our mechanical advantage? 1 equals to, what's our load? Our load is 20 kilogram force. What is our effort? Our effort we don't know, so we give it E. How do we find the value of E? We multiply both sides by E, here by E. E cancels with E, then E times the 1, we get E. We shall say E equals to 20 kilogram force, and this is the effort. As simple as that. Even though they tell you to find the load, you simply substitute, then you'll be able to find the load. Otherwise, thank you so much for being attentive in my lesson. In our next lesson, we shall look at a single movable pulley. Single movable pulley. May the Almighty God bless you abundantly. See you.